We're talking parent functions today. So what's a parent function? Well, let's think about it. I'm a parent and I have children, right? And my children might look a little bit like me. You know, some of them have the same facial features and some of them maybe have the same height as me, but they don't look exactly right like me, right? Some of them might be stretched. They might be a little taller than me. Some of them might be squished. They might be a little shorter than me. Well, all of my children are boys. So they're a little different than me, right? And that's what parent functions are, is they're kind of like the original, right? These are the original functions. And then we copy them and change them a little bit and we get their transformations, or maybe their child functions if you want to call them that. So we need to know these parent functions. We need to recognize them when we see their shape out in the wild. We need to be able to recognize these functions, and then we will learn later about transformations and how we can recognize their equations. But really, today, all you need to do is be able to recognize and graph these. So these are our 12 parent functions. You see all of them here in black. We're going to go over each one of them and see where they come from and how to graph them. So first things first is we have y equals x. Y equals x, you might remember, is just a line, right? But let's figure out how we could know that, right? When x equals 1, we could use a chart. When x equals 1, y equals 1. When x equals 2, y equals 2. When x equals negative 1, y equals negative 1. When x equals negative 2, y equals negative 2. Right? We could just fill this chart out by, putting in values for x and figuring out what y is. So what's that going to look like? Well, we're going to have this point, we're going to have this point, we're going to have that point, we're going to have that point, and that point. So let's see how straight of a line I can draw on this iPad. Not the worst one I've ever drawn. So y equals x is just a straight line that goes through the origin. So that's our first one. This one we'll call, we'll actually write that here, that this is a line. Okay? We could also call it linear, but a lot of times I'll just write a line. All right, y equals x squared. What does this look like? You might remember, but we could always do a chart. When x equals 1, y equals 1. When x equals 2, well, 2 squared is 4. When x equals 3, 3 squared is 9. What about when x equals negative 1? Well, y equals 1, right? Because negative 1 squared is negative times negative is positive. So we have this point, and we have this point, and then we have a point way up there that we can't graph, and then we have this point, and we have this point. So you might remember that this one is a parabola, or we call this a quadratic. That's the name of this one. So x squared is the quadratic formula, or not quadratic formula, it's a quadratic function, and it forms the shape called a parabola. So that's what that little U shape is. Anytime you see a U shape, you know it's x squared. All right, this is x cubed. It's called a cubic. It's really original, I know. Let's figure out if we can figure this one out. When x equals 1, y equals 1. When x equals 2, 2 cubed is 8. What about when x equals negative 1? Well, negative 1 times negative 1 times negative 1 is also negative 1. And what if it equals negative 2? That would be negative 8. So we have this function right here. So it goes like this, and then 8. So it's like way up here. And way down here. So it kind of does this loop loop right there. I know, that's a fancy term, right? It just does this kind of like little, kind of flattens out and then keeps going down here. So this is a cubic. Anytime you see that, it would be y equals x cubed. All right, the square root of x. Well, let's think about this. When x equals 1, well, the square root of 1 is 1. What about 2? We don't really know, like the square root of 2 is like a decimal, right? So let's go the next number that we can take the square root of. Well, we could take the square root of 4, right? So if I put 4 in here for x, what do I get out? What's the square root of 4? Well, the square root of 4 is 2. And then the next number that I can take the square root of really nicely is 9, and so the square root of 9 is 3. What happens when I do negative 1? We can't do the square root of negative 1, right? Because that kind of breaks those rules of math. We can't take the square root of a negative number because nothing times itself is going to equal a negative number, right? So the next one we can take the square root of really nicely is 16, and that's 4. So Let's graph this one. So we have this point, when x equals 4, y equals 2, so that's the only ones we can graph. I didn't give you a very big graph. It goes like this. So remember, negative numbers can't exist here because negative numbers you can't take the square root of it. Now, if you think about this, this is the top half of a sideways parabola. Do you notice that? That if I finished it on this side, this would be a parabola. And you'll learn later about inverses, but that's the reason why this is a top half of a sideways parabola is because of something called inverses. But anyway, when you see this shape of a function, this is a square root. Okay. This is called a rational. And what's the shape of this one? Well, when x equals 1, y equals 1. When x equals 2, y equals 1/2. When x equals 3, y equals 1/3. What about when x equals 1/2? There's a little bit of math involved, but it equals 2. Okay, so this one, we could have graphed each of those, but anyway, you'll learn more about them. We're going to go over a whole unit on these, so I'm not going to mess with that today. But it looks like this. That's a rational function. Anytime you see something that looks like that, you just know it's y equals 1/x, or some form of that. The parent function is that. All right, what about the cubed root? Again, we could just plug numbers in. Anytime you see any function, and you need to graph it, you just plug numbers in and graph those points and connect them. That's it. And once you know parent functions and transformations, which we're going to learn later, you're actually able to already kind of know what the shape is going to be. So when you go to graph it, it makes a lot of sense. So the cube root, I can take the cube root of 1, it's 1. I can take the cube root of, let's see, I can't take the cube root of 2 very well. The next cube I have would be 8, because the cube root of 8 is 2, because 2 cubed is 8. Right? So the cube root of 8 is 2. Let's do -1. The cube root of -1 is -1. And the cube root of -8 is -2. So we have this -1. Oh, sorry, that's not the right point. And then 8, which is over here. And then -8, which is over here. So we've got that little loop-de-loop thingy. You notice that it's the cube root, or the cubic function, just on its side. Yeah, it's just the cubic function on its side. So this is the cube root function. All right, this one is called the greatest integer function. This one we're not going to use the table for because you've never seen it before and you don't have any idea what it means. The greatest integer function basically just says you round down to the closest whole number. That's it. Just round down. So it looks like this, right? If 0 rounded down to the closest whole number is 0, right? And 1/2, when I round 1/2 down, it's still just 0, right? But when I get to 1 rounded down to the closest number is just 1. And so it does this kind of little step. Some people call it the step function. It steps up and it does that. So it's like a pattern because it just rounds down. So if x equals, in this case, -2.5, what's the closest whole number to that? When we round down, it's -3. So the greatest integer function just looks like a little steps like that. Okay? Sine, this is something you're going to learn late in Algebra 2. Sine function just looks like this. It's periodic, which means it continues over and over. It just keeps doing the same thing over and over. So it just looks like a wave. Okay? So sine function is just a wave. You don't need to know where it comes from just yet. That's something for later. But that's the sine function. Now the cosine function looks very much like the sine function. The difference is, see how the sine function starts right here at the origin at 0, 0? The cosine function doesn't start there. The cosine function starts up here at 1, 1. And then it goes down and goes back up and goes back down. So the only difference between sine and cosine is where they start. So they're both a wave. Sine starts at the origin, cosine starts at 0, 1. All right, this one is called an exponential. And we could go ahead and do a chart for this one, right? When x equals 1, 2 to the first is 2. When x equals 2, 2 to the second is 4. When x equals 3, 2 to the third is 8. When x equals 1/2, you guys haven't actually learned this yet, but you might know what to do there. When x equals 1/2, it's actually the square root, so it gets smaller. So basically, this one looks like this. I didn't do the right. When x equals 1, y equals 2. There we go. When x equals 2, y equals 4. I didn't go through the right points. I just kind of like sketched it, but it goes like that, and it has this thing called an asymptote where it approaches that. You don't need to know all that stuff. You just need to know what they look like, right? So if I give you this graph, you need to say, oh, that's y equals 2 to the x. That's all. Okay? The ln of x is another one you're like, what are you doing? This is crazy. It's called the natural log. Again, you don't need to know what it's for, but it looks like this. It looks like the opposite or the inverse of the exponential function. There's a reason for that. So this one is called the natural log. Okay, last but not least is the absolute value. You guys have seen absolute values before, and you know what an absolute value does, right? The absolute value just changes anything that's negative to a positive. Anything that's positive stays positive, right? So let's plug in some numbers. If x equals -1, y would equal 1. If x equals 1, y would also equal 1. If x equals -2, y would equal +2. If x equals +2, y would also equal +2. So it's going to look like this. It's going to look like a V. Because it's like we took a line, right? And we just changed all these negative values down here. We just changed them positive. So that's the absolute value. Okay, so what I want you, for Algebra 2, what I want you to remember is I want you to be able to see this graph and write this thing that's in black, right? So if you can see this purple graph, if I say, what is that? I need you to write the thing in black. If you see the thing in black, I need you to be able to graph it. It doesn't have to look perfect, it just has to look kind of like that, okay? If you're in pre-calculus, I need you to be able to name it as well. So I need you to also be able to say, that's the name of it, the kind of function that it is. But write these down, memorize them, make little flashcards, that'll help you.